Okay. Did that look good? Question 4, solving some trig equations. Now we've got this 4 cos squared x plus 7 sin x minus 7 is 0. Do you remember this morning? Oh, it was fun, wasn't it? Well, we talked about stealth quadratics. Quadratics that aren't really quadratics, they're wearing a big cloak. Well, it's not a quadratic, is it? Because we've got 2 different things here. We've got sin x and we've got cos squared x. If only there was some way of writing cos squared x in terms of sin squared x. So we know that we've got this identity. So if we rearrange that, we've got no way, remember we've got no way of linking sin x and cos x, but we have got a way of linking sin squared and cos squared, so we've got to focus on the squared bit. And if we rearrange this, this says that cos squared x is 1 minus sin squared x. So then we can carefully substitute that in. Our equation now is going to become 4 lots of 1 minus sin squared x plus 7 sin x minus 7 is equal to 0. Now it's starting to look a bit more like it's a quadratic in terms of sin squared x. We have 4 minus 4 sin squared x plus 7 sin x minus 7 is 0. Let's take everything to the other side. 4 sin squared x minus 7 sin x, what would that be? Plus 3. We may feel that we actually want to write this in slightly less confusing terms, so let's use another letter. Let's use t and 1. Let's use t as being sin x, so 0 is 4t squared minus 7t plus 3. We talked about this a bit this morning, about how we factorise these kind of equations. You maybe have your own way that you do this, but I might multiply the first and last terms together to get 12t squared. Can I think of 2 things that multiply to give 12 and add to give negative 7? 4 and 3, minus 4 and minus 3. So if we write this as being 4t squared minus 4t minus 3t plus 3, and then factorise it 2 terms at a time, I've got 4t times t minus 1 and minus 3 times t minus 1. There we go. And so t minus 1 appears twice, so that must be one of my factors.
You know, like you're putting in the t there?
Yeah.
Like it's coming out as 4t squared. And that apply to sin and it? So what would it be sin?
All I'm doing is I'm replacing the sin squared and sin x by t. So this is 4 times sin squared x. Now sin squared x is t squared. Here we go, 7 times sin x is 7 times t. We'll undo that at the end. Okay. Here we've got 4t minus 3. So when we write sin squared x, that means sin x squared. Sin x. Okay, not the separate bits. Here we've got what values? T is 1 and t is 3/4. So it wasn't about t, it was about sin x. So we undo our substitution. Sin x is 1. Sin x is 3/4. Now this bit's easy enough. Sin x being 1. Remember the sine graph? That's probably the easiest way to think about that one. When is sin x equal to 1? It was... I've just drawn the cos graph.
Yes, 90.
Here we had our values. The only time it's going to be 1 is at 90 degrees, so x is 90 degrees. And that's our only solution in the range 0 to 360. Sine x is 3/4, we've got a bit more work to do. That's not one of those nice values. So we're going to do inverse sine of 3/4. Can I borrow your calculator? Guess what people are going to do wrong here? Yeah, the last question that we just did. It was the question before this in the paper, question 3. You had to be working in radians really, didn't you? So your calculator was probably in radians mode. And yet now we find ourselves doing a question that has to be in degrees, giving all values in degrees between 0 and 360. That's just doing everybody watching a big shock. It wasn't me that fell over, I'm alright.
Right, just carry on, please.
We get 48.59. Now, as we talked about this earlier, it's up to you. Use the graph or use the cast diagram. I'm using the cast diagram again.
God help me.
So my other value is going to be 180
I knew this
minus
was going to
that,
happen once.
which is 131.41. And so we're going to give our answers in ascending order. X is, what was it? 48.6 degrees, 90 degrees, 131.4 degrees. And there we go. 6 marks. We'll take that.